Welcome to the Innovation Squadcast, making a positive difference in learning through innovation.
Welcome to Innovation Squadcast, and thanks for making us part of your educational PD journey. We're diving into the fascinating world of robotics and sensors, exploring how these tools can engage students in the collection and analysis of data. We'll discuss practical applications of various technologies available to educators, empowering teachers to create dynamic learning experiences for their classroom. I am Jimmy Kate.
Phil Sheridan.
Eileen Fernandez-Parker.
And we are innovative learning coordinators at Berkeley County School District, and we have some robotics, and we've got some sensors that a lot of people didn't even know about. There's actually a couple on these Pasco ones that I didn't even know existed until I was digging through the boxes. So I'm excited to hear about those. We'll have Pasco stuff at the end, but jumping right into some of the robotics that we have available. You see here on the board, we got B-Bots, we got Dash, we've got Q, we've got Pixel, and what are some ways that you've seen them being able to use these lessons to promote kind of data analysis, math, measurement, and ways to kind of, let students engage with this material to really get some real world practical applications?
So, I guess I'll start. Some of these, like the Dash, for example, a lot of times when we teach kids coding, for example, a lot of it happens on the screen. So the nice thing with some of these devices that we've selected to bring into schools is that you code on the screen, but then it comes to life through the use of these robots. Successfully coding robots to, let's say, navigate a challenge course.
Sure.
It really is about measurement.
Yes.
And working with variables and, problem solving. And, the whole design thinking process, come up with an idea, execute, reflect, revise, and do again. That's really the process. So, these, and they're fun. The kids have fun with them. They light up, they make sounds. So it's an engaging experience.
Sure.
When we bring those into the classroom.
Yeah, I have a second grade class. Shout out to my second grade teachers at Nexton. We're going to do the whole grade level measurement and Dash through a course. They've got to measure basically through the course, fill out the sheet, and then take that sheet and turn it into usable code that will then get them through there. And then if they're successful, yay. If they're not, let's go back, rework the problem, and remeasure and do it again. So
it's good sequential thinking too, which is, we teach it, but to give them an experience, a hands-on experience, an engaging hands-on experience of thinking through sequentially a challenge, like you said, a challenge course, and also being efficient with that too. Letting them look at the way they did their code, and was this code as simple as the code could be to accomplish the task, the challenge. And I think, working with these robots and coding, that's a great way to engage students in real world application of sequential thinking and efficient sequential thinking processes. So
I love that we can really help the kids understand that the task is not to be perfect. The task is to take chances, see how it goes, try again, take more chances. And, equating it to video games for kids, when your little character dies and it goes, they don't give up and walk away. They try again, So that kind of thinking, I think, is more healthy for our kids.
Yes, and then they get to collect, again, all kinds of different data that we can use with our robots, especially when it comes to measurement. I think that's usually the biggest one, and that's with storytelling, that's with group projects, that's a lot of the different elements. Does when it says it goes 30 centimeters, does it really go 30 centimeters? And have that conversation about real world, being able to collect that data and say, all right, this time it went this many, this time, why is there this variables, right? So you got these terms that you can throw out there that kind of help that. And again, Q, Dash, Pixel, all of those B-Bots, they all have that kind of built in. So
I love how also the kids can be estimating too.
Yep.
How far do you think it needs to go? Okay, let's try it.
Sure.
And then just through trial and error, they get a sense of how far something is,
Yep. It's definitely a great way to apply all those different measurement skills. So another one of our tools at our disposal are our code drones. Those are another one that are great when it comes to data collection and analysis. Again, looking at time. This one's different because it moves power, and it moves in time. So it doesn't move in centimeters or inches or things like that. So how, and being able to, have that kind of ability to survey a space, collect data from where it flies based off of those kind of different measurements are really powerful, engaging tool as well. So.
Yeah, no, working with those, the different propeller, the powers and things like that. That is a lot of times when we say data, it's like this data. What is data?
Yeah.
Yeah.
And its data is, in a second we'll talk about actual sensors, that collect specific data like temperature and other environmental factors. But data that you're working with on robots is just the data that's coming from the different motors that are turning the wheels and the numbers that that can vary, that affect the performance of whatever that is. So I really like the co-drones because it really gets you into really fine tuning some of those little variables when it comes to power and acceleration and things like that. It makes a huge difference with being successful through a challenge course or whatever it is that you want to do. And I think that's really important that they learn about that. So
and there's great ways for them to be able to access like things like Google Sheets and being able to learn how to navigate a spreadsheet and import data. And depending on the, the level from, we can do this from K all the way to 12, right? Real simple sheet of just importing a number all the way up to, our secondary people where they're actually learning how to build formulas and find those kind of different data as well. So
I think probably important to point out in case anybody's getting excited about drones, though, is the requirements for that experience.
So whenever you're looking to do the drone experience, that's something that only our team can do right now. We have to have an FAA certified pilot there. We have 3 on our team that are able to do that. And so, we come in, we have to have a closed space with a tent, but we've done it with many schools so far. It's going great. So
that tent's pretty big. You have a good space for
it's 10 by 20. So a good multi-purpose room gym is a good place to set that up. So.
Cannot be outside.
Nope.
Does not work.
No. Don't work outside.
You guys learned that?
Yep. These are just for kind of indoor education use only. So, so they're great for that, but
super
not so
light,
great.
so they get blown right around.
Right, they do. So an 11-foot ceiling would be okay because the 10-foot tent would fit inside it.
It pushes it, but it should. So, and again, lots of opportunities there when it comes to data collection, whether it's within the space, whether it's the competition or anything like that. So another wonderful example that we've got is going to be the robotic dogs. I think those are, we've been utilizing them specifically, at our truck and events and things like that to kind of highlight and then I was able to kind of utilize them a couple times in classrooms where the students were either measuring its speed, right? It went from point A to point B, right? That's a pretty simple task, but because everybody wants to know how fast it is, right? And so, Jeremy, you want to pull one of those up on the screen real quick, and just so they can see what it looks like. Yeah, so that's what the Unitree. I don't know if this is our version or not, but and so because they have a couple different versions. The new version now can do like flips off of stairs, and all kinds of crazy stuff. Yeah.
Wow.
So that's what ours looks like. So whether you're I brought it in where you're analyzing its movements and analyzing speed and doing different types of science experiments, creating an obstacle course for it, and then also getting data. Is another one of the experiences I've done with this one. This is great also for storytelling, for get a kids excited about writing. I know we're not talking about writing today, but I love this one and being able to get kids writing about this dog. It really kind of jacks up the engagement levels. So
and it has sensors too, right?
Yes.
So what data is it collecting?
Well, I mean, one of the things, the motors that we have in there, there's a bunch of motors. They have temperature sensors in them, which is important for the health of the dog. You don't want to overheat it, so we can check those things out. It also has proximity sensors for distance sensing and things like that, which are built into the code that helps to keep it from, running head on into an object, and gives it the ability to do the follow me features. But what I also do a lot with this is have conversations around what sensors could we equip this thing with that would take it beyond what it currently is. We see these things being used in military, law enforcement, fire and rescue. So we ask, we start to get into what kind of sensors can sense the environment around it to give information remotely back to, let's say, fire and rescue people. So really gets kids into researching, like, what are these things? And then again, kind of that design thinking, thinking beyond what they have in front of them and making this thing into something even more functional and innovative than what it currently is. So this is a great way to just capture attention and minds of students,
yes, it does.
Getting them to think beyond, just the normal, their normal way of thinking. The dashes and all the stuff are fun and engaging, but I think for a lot of kids, they've seen something similar, before in school or even maybe at home. But this is like, I only see this stuff on the TV,
right?
So that's really cool to bring that in, and everybody loves to, get their hands on controlling it, and driving it. So it's a great motivator and an engaging tool to bring in.
Yes. So again, with all these different experiences,
not a borrowable thing.
No, that's something. Reaching out to your ILCs will be, again, more than happy to bring those in. We've got two ones currently out getting
tuned up.
Yeah, getting tuned up and ready to roll.
Yeah, they get a lot of mileage on them, so they need a little tune up. So,
but yeah, reach out to your ILCs, and that's where all these experiences will more than happy to come again, support whatever standard that you're working in when it comes to data analysis, measurement, math, whatever. We're more than happy to support any of that as well. So, two more, probably the biggest pieces when it comes to data collection that we're going to be talking. That was just kind of the early stuff and the robotic stuff, but we've also got a significant number of different sensors that you can use to really collect a significant amount of data through what we like Pasco, because we're going to talk about Pasco and microbits here. We'll start with Pasco. Phil, turn it over to you, our Pasco expert, our kind of gathering real-time data, enhancing science experiments and data skills. What can we do with all of these different sensors that we've got here? And feel free to grab and demonstrate whatever one you...
our science teachers really get into doing a lot of this. I was a science teacher as well, so I've got that appreciation for these what the sensors can offer up when it comes to investigative inquiry, thinking, and all of that, and just the scientific method.
Right.
That process. So we have, just sitting out here in front of us, we have, like one of the real multi-tools of the sensor world is this little guy right here. It's a weather sensor, and it's just packed full of all kinds of different sensors to collect information, like, wind speed, monitor, barometric pressure, temperature, humidity, all those, everyday environmental factors that affect our weather. But in addition to it, also has GPS built into it, which is really cool.
Yeah, we just had a geocaching experience with that, being able to collect different data points and find it.
Connects to your Chromebook, and then, you can use the GPS sensor to collect if you're out doing a geocaching experience and you wanted to collect your walking, where you walked with this, and then you can pull it right into Google Earth and then take a look at where you walk. So if you're even surveying like a certain area and you wanted to see what that area was, you can use this. And then it also has a light sensor in it, and it can sense different levels of light. And people oftentimes, it's like, well, you mean like the lights are on or off if it's how bright it is? Well, yes, but it also senses different wavelengths of light, like the light that's used for photosynthesis to grow plants. That's a specific wavelength of light. Or the light used for solar panels, also different. It's not the same. It's not the same light that plants would use. It's probably fair to say a solar panel and a plant in the same area would probably benefit just the same, but they are two different wavelengths of light. So this thing is just packed full of all kinds of stuff. Doesn't just have to be weather. And then we have some, more specific things like health monitors. It's like EKG stuff and pulse, and great for just kind of getting data about your body. Motion sensing equipment like accelerometers and force sensors. So great for when we're doing different experiments like, hey, let's do package engineering. Let's design a package that can safely keep an egg intact when we drop it. Well, let's collect data about when we do this, how effective is our packaging?
What I love about all of this is how real world it is. A teacher that I taught with, her daughters went to Clemson, and one of them came out as an engineer, a packaging engineer, making $100,000 right out of Clemson. So when kids hear that kind of stuff, they might really be interested. You know, you get their attention.
The other thing too that kids seem to latch onto when we talk about sensors is the, we got our little accelerometer sensor here. We love to shove these in Nerf footballs and have a experience where we look at the data of football, like throwing a football, running and catching and all that stuff. This little guy here can collect all that. But then we say, well, inside of this little white packaged thing is a piece of technology that's also built into your watch. It's built into your phone. And that's how, when you're out in your everyday life, how does your phone know that you've just walked or you were exercising? Or how did my parents know when I was, I drive as a teenager and Life 360 just alerted them that I'm driving aggressively? How does it know that?
That's right.
Well, it's the same technology that's in this. It's in your phone, and it's just connected through an app, So they really start to, you can see those little light bulbs go on for the kids.
What's great about this too, Jeremy, if you want to pull up clicking the actual sensor data on Pasco's website right there, that they get numbers, they get graphs, they get charts, they get pretty much anything that they wanted to kind of create and collect, and it's pretty simple. You just kind of turn one on.
It's Bluetooth. So
right, it's Bluetooth
connects
enabled.
to Chromebooks.
Right. Of course, this one doesn't have any power or battery.
I think it's...
You want to turn one of yours on?
I'm trying to turn one of these guys on.
Yeah, you just be able to connect Bluetooth straight. Yep, there it goes. Straight to it, pair it, and now you've got all of this different data that you can collect. And then again, what's great is you get graphs, you get charts, you get numbers, you get all types of different data points over there to be able to do any of the monitoring. And it's customizable that you don't get everything if we're just going to be looking at whatever
so if we
wind
wanted,
speed.
do, light illuminance. There you go. Don't do wind speed. Yeah, actually, wind speed's good because that way I could show you. Then get rid of temperature. We don't need that. It's not going to change if we're trying to do a quick little demo. And then you can just do the table and graph. So we see the actual numbers, but we also see in real time the graphing. Time. Yeah, that should be good enough.
Yep.
And then just hit start at the
Start
bottom.
down at the bottom. Yep.
And then so you can see the wind speed as I, spun the little fan that's in here, and then the light sensors at the bottom, so you can see in real time now the light is down to 0 because I got my hand over it, and then I bring it back out, and now the light goes up. So
And now they've got the ability to be able to read a graph, to interpret a graph, to grab data from a graph. And then they've also got this chart over here with all kinds of great numbers as well. These are all savable to their Chromebook. And then, and then however you want to utilize that data, depending on whatever standard you're working on, I think is the power of these.
Yeah, it's really great. The rocket launch experience where we we put one of the acceleration altimeters in it. It's great. It shows, what a parabola looks like, but then they actually can correlate something that has previously been taught and just shown on a piece of paper to real world outside. Now it makes sense kind of data. So those Pascos are really easy, just kind of plug and play, ready to roll. And then I guess we would then transition over to a little bit more diverse, perhaps, the microbits.
Yes.
Before we move to microbits, what's the youngest age that you think could handle the data that's coming up? Because at a very young age, the kids are responsible for understanding how to read a graph, right? So, could second graders
I think
do
they
this
could.
if it's simple enough?
I think so. I think you can pair it and scaffold it. I think, however, to meet the needs. I think that's what's great about it is we can get as intricate and as detailed for our upper grades, but I think we could also keep it pretty simple. This is this is faster, this is slower, right? Just even showing that, I think, is a powerful thing.
Why the line go up?
Right.
Why is it down? I mean, just simply, doing the whole, wind speed thing, blowing on there.
Yeah.
It's showing no speed. Why?
Right.
I think that is great, good, inquiry-based experiences for kids that are simple to create.
Right.
Yep.
As a teacher.
So so we got temperatures. We've got, I don't even know what's the spirometer.
That one's shows you how much your
No
how
way.
much air your
Oh, it's
lungs
like a-
can hold.
No way. So definitely
A
like whole science
breathalyzer
classes. So,
almost.
yeah, I saw the EKG
Yeah.
one
That's
as
cool.
well. So yeah, we got lots of good
Yeah.
stuff.
Yeah.
And the force, yep. And then so definitely reach out to us, see what we got. And
In the middle schools, they have medical detectives as a class.
nice.
We need to pull those out.
Yeah. Yeah. No, those are fun.
All right, so let's transition now to our last bit of data collection technology that we got, and that's microbits.
Do that on purpose.
Huh?
Last bit.
No, there was no pun intended. I'm not that smart to come up with
Ba-dum-bum.
puns on it.
Yeah. So the microbit is kind of like wrapping together concepts of robotics, coding, and it also has our sensors into it. And it's a very unassuming little device here that right out of the box just needs a connection to your Chromebook. Make Code is the tool that we use to do block coding with it. And, with that coding platform, we can take this device and we can say, hey, the light sensor on it, when the lights go off, beep, because it has an output device on it as well,
Right.
So it allows students to kind of create their own sensors with the sensors that are built into the device.
Right. You can connect humidity and temperature. So a lot of the same things Pasco does, but with some coding built in.
This is just ready to go.
Right.
Like,
And
you
if
want
you're
temperature, there you go.
coding class, it's great. If you're not a coding class, we can show how to use AI to help build the code. If that's something that they're interested, you've had a lot of success using the Magic School AI for creating some of the code to kind of streamline that process as well. So that's another good tool to use. So.
Yeah, even like back to the light sensor thing. What happens in school? What happens in buildings when the lights go off? Well, the exit sign. There's a little light that comes on.
Right.
So let's use the light sensor in here and the output features where it can control things, and let's turn on a little red LED light when the lights go off.
Yeah.
And all that's done very simply through the code platform that they offer, and it's a lot of fun. And really, what this thing is, the microbit it's a microcontroller. So micro being small, it's obviously small, and controller meaning that it can receive inputs and it can control outputs. And the inputs are the sensors.
Right.
So
Yeah, whether it's weather collection, it does a pedometer, which is a really fun tool where the kids can measure and track and get data of, all right, how many steps did I take in 10 minutes, or walking around the building or something like that, and then grabbing that data and then actually using it.
And you can really, like you said a moment ago, you can really embrace AI with these things.
Yes.
And I've been blown away with using Raina in Magic School and just talking with Raina about, hey, I have a microbit and I want to create a fitness tracker.
Yeah.
And it walks you through all of it, gives you the code, and just create it, So it really makes me think differently about like how I approach coding with especially students who've not done it before. Like, what's the entry point to that now? When we have AI, has just like vastly accelerated our abilities to jump right into just the creation piece, not held up by or slowed down by our lack of ability to code. But so I love these things.
Yeah.
I have a ton of fun with them. I nerd out.
What I love about them is the instant gratification. The kids get their hands on it, and the programs are on the website. So, and it walks them through how to do it. And then when they do it and it shows the heart or it blinks their name, or they are so excited, And being the English teacher, I'm going to have to just talk about how English teachers can do technical writing and how-tos with their students.
Yes.
So this shouldn't just be for science and math, because if we have good writers, technical writing is a really good career.
Yes.
And having something fun like this and then breaking it down into the steps to be able to do it is also a skill. So, yeah.
Nothing more frustrating than getting a new piece of technology with a really poor technical manual on it.
Yes,
So
yes,
this is
it's true.
Important
Yeah.
if you're that type of person that reads it. But the other thing with AI that I flaked out on a second ago was Microbit now uses AI in their, what are they calling it? Can you go to the homepage there, Jeremy, for Microbit? Just click the logo. Yeah, Create AI.
That's right. Yeah.
And this is really cool because it gets students to see how do I create how do I create a smartwatch like
Right.
this? How does this thing know that I'm doing jumping jacks, which I don't do jumping jacks. But how does it know that I do jumping jacks? I'm walking, I'm running, I'm lifting weights. How does
Right.
it know that? Well, it's been trained to know what a data sample looks like that is indicative of that type of activity. So
Right.
with this, you can train it to
look for different data collection points.
Different data collection points. So if you wanted to make a fitness tracker out of this,
Right.
like it gets kids into the mindset, okay, we got to train this thing to know what jumping jacks looks like.
Right.
And it's pretty impressive.
It is, yeah.
And this is a new feature they just came out with, which I haven't had a whole lot of time to mess around with, but excited to explore more.
Absolutely. So hopefully everybody learned a ton about data collection. Maybe they got some ideas. We'd be more than again happy to talk and have those planning meetings. So reach out to your ILCs, and we'll be happy to have those conversations to be able to build these learning experiences for our kids, where the ability to collect data, use that data, and connect it to all of the standards that they've got going on in the classroom to really ramp up the engagement, ramp up the achievement, the motivation, and deeper learning as well. So don't forget to subscribe to the podcast on YouTube or wherever you get your podcasts so you get new episodes. Don't forget about the Innovation Squadcast PD, where you can earn renewal credit by clicking the link in the show notes to take you to Unified Talent Register. There's a form in there, a Google form. After you listen to 2 episodes, fill out that Google form. You get 1 hour of renewal credit. And again, if you want to be on the podcast or have an idea for the podcast, please reach out to your ILC so we can set up a time for you to come on and share your expertise and all the wonderful things going on in your classroom. So thank you guys for being here and sharing your experiences with data and sensors. Thanks everybody for listening. Until next time, keep innovating. Bye.